Hey everybody, this is it. This will be the last video, I think, for this semester. Just going to do a bunch of examples from section 5.4, so I hope you enjoy and start studying for that final exam. Okay, let's see what we got here. So, remember what a logarithm is. It's the inverse operation to an exponential. So, if we look here, right? Log base a of x is y, means the same as a to the y equals x. And so we can undo exponential functions by taking logarithms, and so if you look what happens when you take logarithm with the same base of an exponential, right? The log and the exponential part, they cancel out. You just are left with the exponent. So log base a of a to the x is x. By the same token, a raised to the power of log base a of x is just x. And that's just by the definition of logarithms. So this simple logarithmic equation can be solved just by switching to exponential form. So if log base 2 of x is 6, well then if we think about switching that to exponential form, one way to do that is to just put whatever the base is raised to the power of both sides, and you can see that the 2 and the log base 2 will cancel in some sense, and so we're left with x is equal to 2 to the 6th power, which is, I don't know what, 2 to the 6th power, 64, right. 2 cubed is 8, so 8 squared is 2 to the 6th. So that's when I'm 64, as Paul McCartney would say. Okay? And of course, if you wanted to check your answer, right? Then, and you should always do that, because remember the logarithm has domain only positive numbers. So it could be that when you raise both sides to raise a number raised to the power of both sides, you might introduce some extraneous solutions. That doesn't happen here. We only get one answer, but if we wanted to check, we do log base 2 of 64 and see what that is. Now we have to use the change of base formula to put that into our calculator. So ln of 64 over ln 2 is what we hope it to be, 6. Yes, of course. Okay. So let's do a bunch of examples here. What's some more? If we have exponential function, exponential equations, the general idea is we isolate the exponential part and then take logs of both sides, logarithms of both sides, to switch to logarithmic form. So here, part A, the exponential part is actually already isolated for us. So we don't have to do any algebraic manipulation on the outset, but we take log base 10 of both sides, and remember log base 10 is just log, no base, right? That's the common logarithm. Then that switches us to exponential or to logarithmic form. So the log base 10 and the 10, they cancel. So we're left with 3x equals log of 100. Log of 100 is the exponent you raise 10 by in order to get 100. And 10 squared is 100, so log base 10 of 100 is 2. And so then we can solve for x. X is 2/3. Okay. Generally speaking, in my math lab, if you have a chance to write an exact answer, write the exact answer. But if not, then pay attention to how many decimal points the exercise is asking you to change it to. Okay. Now notice in part A, we could have done this another way. So if you notice 10 is equal to, 100 is equal to 10 squared. So one property of exponents that I didn't have you recall was, so let me actually make a separate note of this. So if we note that I could have rewritten 10 to the 3x equals 100 in this form. 10 to some power equals 10 to some other power. And that means that the powers must be equal. Okay, we saw that when we took logarithms of both sides up here. Okay, but so you arrive at the same answer. But notice if you have two things that you can on either side of an equation that are of the same base, and you can rewrite it so that you get a to some power equals a to some other power. The exponential function is said to be 1-to-1, which means it doesn't always, it not only passes the vertical line test, it also passes the horizontal line test, which means if you have the same y value, then you're going to have the same x values. But this method of equating the powers only works if you can rewrite it to look just like that. Okay. Now part B definitely had non-like powers, right? 37 is not equal to 10 to some whole number power. So we have to do it the other way. So first and foremost, we would, no matter what, we would have to divide both sides by 2 to isolate the exponential part. I don't know about you, but I don't know what power of 10 is equal to 37 over 2 just off the top of my head. So I'm going to take log base 10s of both sides. To get 3x is equal to log base 10. It's common log, so you can just write log 37 over 2. Divide both sides by 3. Now that is the exact answer, okay? But if we wanted an approximate solution, we wouldn't have to use the change of base formula because we have the log base 10 on our calculator already, and any scientific calculator would also have it. Parentheses here really matter, okay? Don't mess up the parentheses. You get about 0.4225 I didn't say what number of decimal points to round to, but your calculator will, or sorry, my math lab will tell you. So pay heed to that. What about e to the negative x equals a half? Well, so we already have the exponential by itself, so I'm going to take log base e's of both sides, but log base e is the natural log, and that has notation ln. So the ln and the e are next to each other, so they cancel out one another, and you're just left with negative x equals ln of 1/2, which means that x is equal to negative ln of 1/2. Now, by the properties of logarithms, that would mean this is the same as ln of 2, but either way, we can stick this into our calculator. Negative ln of 1/2 is about 0.6931. Notice that that's the same as ln of 2, but you don't really have to know that in this section. That's more for a next section, and we're not covering that in this course right now. So if you wanted an exact answer, this would be an exact answer, but your homework will ask you to evaluate this. So just follow the instructions. Okay, what's part D? So this is a question about how long does it take for an investment of $250 compounded monthly at an annual interest rate of 5% to get to $10,000. Right? So this question is, I could rewrite this question as, how long for an investment of $250 at a rate of 5% compounded monthly to reach $10,000. Should be a long time, actually. All right, if you were out there trying to guess and check at the answer, that's not the right way to do it. Okay, do not guess and check. So we need to solve 10,000 equals 250 times the quantity 1 plus r over n to the nt. Okay, this is just an exponential function. Exponential equation. I need to isolate the exponential part. So divide both sides by 250. 10,000 divided by 250 is 400. Right? Oh, shoot. My arithmetic. 40. Okay. Good. Okay. So I'm solving 40 is equal to whatever this number is to the 12t. So I take logs with whatever that base is, both sides. Log base 1 plus yada yada yada, both sides. Leave myself enough space. base 1 plus 0.05 over 12, all raised to that same amount. So it goes away. And what are we left with? We're left with some number of the form log base something of 40. Remember, this is just a number. This is some number. I don't know what it is, but it's a number. Equals 12t. So this, whatever it is, divided by 12 is the answer. But if I use the change of base formula, let me not skip steps here. If I divide both sides by 12 and then take the change of base formula, so we get 1 over 12 times log base 1 plus 0.05 over 12 of 40. Change that, so that's going to be equal to t. But change this expression into something we can evaluate on a calculator, like ln 40 over ln of 1 plus 0.05 over 12 to get t. So ln of 40 divided by, don't round off intermediate steps, by the way, or you may compound your round off errors. So first I'm getting whatever that logarithm was. It's 887. Divide that by 12. So it would take about 74 years. Okay. So pretty cool. So if you invested $250 now in a mutual fund that gives you 5% interest compounded monthly, by the time you are 74 years older, you have 10,000 bucks. Okay. It's not meant to discourage you from investing, but maybe so. All right, last thing here. Let's just do these logarithmic equations. Raise to the power of both sides the log, okay. Sorry, you raise the power of both sides with the base of the logarithms, okay, and the logarithms will go away. Here, this is a exponential, so we would have to do logarithms of both sides. So you need to be able to toggle between exponential form and logarithmic form as the case is needed. So if I raise 3 to the power of both sides, you see that the logarithmic function is also 1-to-1. Okay, so if you have log base whatever of something equals log base the same whatever of something, then you can just take what's in the parentheses and make it equal, because that's what you would get if you were to switch to exponential form. Okay, so this is a quadratic equation. Don't forget that the semester before, or all the sections before this section, still exists. Okay, so you need to be able to do some of the techniques from previous sections, perhaps. This is a quadratic equation that factors, and so x is equal to -2 and 3 is the solution set, right? Except, oh, and it works out, right? So even though this is a negative number, if I plug it into both sides, I get of the equation, I still get equality. So log base 3 of 4 is the same as log base 3 of negative 2, the quantity squared. Right? Need to check your answers though. Sometimes there isn't two answers, and usually the negative one, when you plug it back into the original equation, you get something that is not valid. Okay, so make sure you do that. Now, part B, 1 over 25, notice that that is 5 to the negative 2 power. 125 is equal to 5 to the third power. So when I do 1 over 25 is equal to 125 to the, what was it? Negative x plus 2, I can do this using the like bases method. So I get 5 to the negative 2 is equal to 5 to the 3 to the negative x plus 2. Okay, so I can take log base 5s of both sides, and that gives me negative 2 is equal to 3 times the quantity negative x plus 2. This is just a linear equation. So 3, negative 3x plus 6 on the right hand side. Subtract 6 from both sides, divide by negative 3. So x is 8 over 3. The answer to part B. Of course, you'd want to check your work. Okay, so 125 raised to the power of negative, what did I say, 8 over 3 plus 2. I read that wrong. Oh, yeah, sorry. I'm trying to get 1 over 25. That's right, not 25. 1 over 25 is 0.04. Okay, good. So it checked out. Didn't make any mistake. Good. All right. Last couple of things here. 3 times e to the x equals 19. Just like before, we're going to get e to the x by itself, because that is the exponential. We need to isolate that part. And then take ln of both sides. ln and the e will cancel, and we're just left with ln 19 over 3. That's the exact answer. And we can figure out what that is as a decimal approximation, about 1.85 roughly. Okay. What's part D? ln of x squared minus 4 equals ln of 5. Okay, so the base of ln is e. So if we raise e to the power of both sides, then that will eliminate the logarithms, and it switches us to exponential form, which in this case just ends up being a quadratic equation, x equals plus or minus 1. It ends up being all of those are valid answers. Right? There are no extraneous solutions this time. Okay, what about log of 9x minus 100 equals 4? Well, the base of log, where there's no base there, is assumed to be 10, base 10, right? Common logarithm. So log, or 10 to the log, base 10, will cancel themselves out. And what we're left with is 9x minus 100 equals 10 to the fourth, which is 1 and 4 zeros. So x is equal to 9,900 over 9, which is 1,100. That right? Oh no, I didn't do it right. It's 1 plus 100. Add 100 to both sides. Get 10,100, and then divide by 9. And I don't know what that is. That's the exact answer. So it is about 1122 and 0.2. 2 repeating, right? All right. Say you have no idea how to do any of these. Graph both sides. Okay. So take y equals graph one side, say log of 9x minus 100, and the other side, graph it. If you don't know what the answer is supposed to be, then you won't know what your window is supposed to be. But I know the answer is about 1100, so let's go from 0 to 1500 by hundreds. And I know it's got to go to y equals 4, so let's go from 0 to 5. There's your logarithmic part. There's your horizontal line. So then we do second trace 5. Enter, enter, enter. There we go, and that was right. Okay, so keep practicing. Do all the homework and the quizzes. Make sure you get those done ASAP so you can start getting ready for the final exam. All right, see y'all later.